Class, what's up? Welcome to our first video of Chapter 5, last chapter before break, which is pretty good, pretty exciting. This first video is a lot of what I would consider or hope to be a lot of refreshing, okay? Things that you have seen before in Algebra 2, and I am just here to refresh these ideas because we are going to be using them for the next couple of weeks. All right, so we start right here, this first box, exponent rules. You guys have to know these, and hopefully you do. X to the negative n, all right, what is it? If the exponent's negative, drop it like it's hot, right? So what am I going to do here? Because it's x to the negative n, I'm going 1 over x to the nth power. All right, 1 over x to the nth. Now please be really careful. This is just the reciprocal, okay? And we'll see this in a little bit, but x could be a fraction, right? If it's 5/3, then what happens? It would become 3/5. So just be on the lookout for that. What happens when the negative exponent is already in the denominator? Well, you bring it to the top. So this would just become x to the positive m, all right? So really, guys, when you see this negative sign in the exponent, you're basically always thinking reciprocal, 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 and then change the sign of the exponent, all right? If we start with something like this, 1 over x to the t, we can rewrite it, and sometimes it will be useful. We can write it as x to the negative t, all right? And then the last one, probably one that you maybe have forgotten, when you have a fractional exponent, that is a root, okay? It might be a square root, it might be a cube root. What tells us that is this denominator here, okay? It's always the bth root, all right? Or whatever the denominator is becomes the index of your radical. All right, so there's the first few. Please make sure you're feeling good on those. And then these next 4, I think, will be nice and easy, I hope. All right, this is what I would consider product of powers, okay? I have the same base being multiplied together. So what we always do is we add the exponents together. Okay, if you see common bases being multiplied together, then the exponents add. Why does that work? Well, take x squared and x cubed, for example. Okay, if we write it out, this is x times x. And if we have x cubed, x times x times x, well, what happens when we multiply them all together? You get x to the 5th. All right, so that is a quick explanation as to why you add the exponents, right? 2 plus 3 is 5. What happens in this next one? Well, now I call this a power of powers. All right, and this one's cool. This one, you end up multiplying. All right, and now if we do a little example here, again, let's say I have x squared, and then I raise it to the 3rd power. Well, that is the same as x squared times x squared times x squared, or this is 2, 4, 6 of them, okay? So 2 times 3 is 6. So that is why you multiply in that case. All right? If you see something like this next one, xy to the s, it's really just like distributing, okay? What we can do is we can say that you can take each piece of the product and raise it to the sth power. And then lastly, anything to the 0th power is always 1. All right? Okay, so let's jump into some of these examples, see how these work. I think you guys could probably do a lot of these already. We know that because we have product of powers, right? I have two of the same base being multiplied together. I'm going to add these exponents. X plus 3x is 4x. Now, I'm okay with this just for now because we're just talking about rules of exponents. If we wanted to go further, we could say that this is 16 to the x, right? Because 2 to the 4th is 16. When we look at this next one, 2 to the x to the 3x, we have to do what? We have to multiply, right? Power of powers. So here it's 2, and then we need to multiply x and 3x together, which is 3x squared. Or here, if I wanted to go a little further, I could go 8 to the x squared. But again, this is all I just want to know that you're learning these rules. All right, on this third one, just be careful. This 2 is not in parentheses. It is not being squared. So you have to take care of the parentheses first. which means I'm going to leave this 2 out, and I have to 3 squared. Okay, 9 x squared is x squared, and then I would finish this up by saying 18x squared. Be super careful on this next one. Be really, really careful here. Guys, there are no parentheses around the -5. Okay, there are no parentheses, so this is actually just 5 to the -2nd power. So what am I going to do? Well, I'm going to bring it to the top, and I'm going to change my sign of my exponent, sorry. Now you have to remember, this was originally divided by a negative, so what happens? There should still be a negative, okay? Be really, really careful there. This negative was not inside the parentheses, so it is not part of the raised to the -2nd power. So to finish this, we could say -25. And then lastly, whenever I see this, that's always a 1, so 418. All right. So there's some refreshing on exponent rules. Now I need to go over common base, the common base. When we are solving exponents or exponential equations, it is always one of the best options to look to see if you can get a common base. Okay? Because if x to the s is equal to x to the t, then s equals t. And hopefully you guys can see that, right? If I have 2 cubed equals 2 to the x, there is absolutely no options but for what? X has to be 3. All right? So this is kind of what we're trying to get to in all of these. So we want to get, when we make the bases equal, since the equations are equal, then exponents, are equal. And that's the trick. That's what's going to unlock these problems for us. All right, so let's jump into a couple of examples. The first one's nice and easy. Already have common base, so I can already set the exponents equal. Boom, done. Easy. Next one, slightly harder. You need to probably practice some of your powers, all right? I see a 3, I see an 81. As a math teacher, I know that I can rewrite this 81 as a power of 3. I don't know if you guys can, so you need to brush up on these. I'm going to leave this as 3 to the x plus 1. I'm going to rewrite 81 as 3 to the 4th. Okay? I do that because now I know that x plus 1 must equal 4, or x has to equal 3. For the next one, I'm just going to leave it how it is. If you don't like fractions, you can always bring them both up to the top by changing them to negative exponents. But I know that if I have this 7 in the denominator here, which I'm okay with, I need to see if I can make this 1 over 343 in terms of a 7. Okay, so we can do that. And what it is, where it's going to be 1 to the 7th, it's not going to be squared, right? Because squared would be 1 over 49. But what about cubed? What's 49 times 7? 63, 280, 63 plus 280, 343. Got it. Okay, so I know that 1/7 to the x is equal to 1/7 to the 3rd. So now x is equal to 3. Nice and easy. All right, moving right along. Next one's a good example here. All right, I have a 2 to the 18th. I have a 4 to the 3x. I'm going to say I can definitely make a common base of 2, which means I don't need to do anything to the left side. However, I need to change that 4. That 4 I need to change to what? How can I rewrite it in terms of a 2, base of 2? 2 squared. I know you all said it. So 2 to the 18th equals 2. Be very careful. This is power to a power. So I'm going to multiply those powers together. And then I can set my exponents equal, which means I can get my x value. At any point, guys, it's also okay for you to plug in to check. This one might not be easy, but if you plug this in, 4 to the 9th turns out to be 2 to the 18th. I mean, or you can plug it in anywhere, really. You could plug it in right here, and it would probably make a little more sense. On this next one, be very careful. I see lots of common errors here. I see lots of people saying, well, 8 is just double of 4, okay, so I can turn this into a 4. No. No, no, no. Bases. We need to use common bases, and we need to use exponents. There's no way for me to write this as 4 to the power of anything. Well, not in a nice number at least. What I need you to see is that I can rewrite 8 power of 2, or base of 2, excuse me. 2 squared, 2 cubed. All right? Because now we can use our power to a power rule, so we have 2 to the 2x equals 2 to the, make sure to multiply out, so 3x minus 3, and now this is a nice problem. What can we do here? Negative x equals negative 3, x equals 3. Lots of 3's here. Okay? Okay. Next one. E. E is an idea that we haven't talked a lot about, actually really at all. You'll see it a lot in calculus. It's just another number. It's called a natural number. It's irrational. It goes on forever. It's like, for what I care about, 2.71. Okay, E is approximately 2.71. Just so you have an idea of where it is, but again, it's kind of like pi. It's a similar number to pi. I see E in the numerator, or sorry, I see E here. E, okay, so let's just rewrite all of these in terms of E, base of E. So e to the negative x squared I'm going to keep. I'm also going to keep this one. This I'm going to change to what? How can I rewrite e to the, if I see e to the cubed, sorry, e to the third power in the denominator? Okay, I can rewrite it as e to the negative third. Because now, if I use some of my rules, I can get something like that. And we have a common base, so I get negative x squared equals x minus 3. Oh, what do? Alright, so now I would need to solve this. At this point, guys, I hope you see that you cannot factor that. So we would have to go and we would have to use the quadratic formula. Alright, so let's do it. X equals negative b plus or minus the square root of b squared minus 4ac. Alright, so something like that, all over 2a, or 2. Alright, so x equals negative 1 plus or minus square root 13 over 2. And for all that I care about right now, that's good. Okay, I want you just to be able to use the quadratic formula. Okay, let's move on. A couple more, and then we'll start graphing. All right, up at the top, looks like we have base of 3, base of 3, base of... Okay, this is good. So we just have to kind of use some of our rules to clean this up. So I can change this to 3 to the 4x times 3 to the x squared, and I'm going to change this to what? If I see 3 in the denominator with a negative, I'm going to bring it to the numerator with a positive exponent, okay? Last thing, or not last, but almost last, I have a product of powers here, right? I have common bases being multiplied together, so I'm going to add. All right. Now I can say that the exponents need to be equal to each other. Keep going. I can factor this one, right? What do we got? X and x plus 6 minus 2? Okay, good. So x equals 2, x equals negative 6. You guys got this. This is easy. We can do all this. All right, last one. Oh my goodness, they're going forever. So I can rewrite 64 as a base of 4. So let's do that. Let's keep this left side together. I'm going to change my 64 into 4 cubed. So 4 to the x squared minus 7 equals 4, and this is a power of powers, so I have to multiply. Now I can set equal, the exponents I should say, I can set equal to each other. I can rearrange, and I can factor. Okay, boom, boom, x and x. What do we got? -7, +1. All right, so x equals -1 and 7. Okay. Whew. Yikes, that was a lot. That was good. That was good. You guys are going to be all-stars at that. So now let's jump into graphing. Graphing, not that bad, okay? Don't stress too much about this. What I need you guys to understand is some situations about exponential growth, exponential decay, and really all of this, at the end of the day, you can always just plug in a few numbers to get a general idea of the graph, okay? So if I'm trying to graph y, which is equal, or y is equal to 2 to the xth power, that means 2 is my base, and I just need to plug in a few values to kind of figure out what this is going to look like. So I usually start by plugging in 0 for x. And why do I do that? Because that's the easiest thing in the world. Anything to the 0th power is always 1. So 2 to the 0th is 1. 2 to the 1st is just 2, right? 2 to the -1st, remember, we can rewrite 2 to the -1st is the same as the reciprocal with a positive exponent, okay? So this is just 1/2. And now when I plot 1, 2, -1/2, all right, I know that I'm going to have something like this. All right, one thing to think about here, this is going to be what we call asymptotic to the x-axis, okay? Exponential functions are always have a horizontal asymptote. And the reason is because as you make this number, so like -2, -3, -4, what's really happening is you're still going to flip it, so it's just going to make this 1 go up. So it would be 1 over 2 squared, or 1 over 2 to the 3rd, or 1 over 2 to the 4th, which is just making a smaller and smaller fraction, getting closer and closer to 0. Okay? So what I want you to notice here, growth, this is happening. Why? I can see it because it's getting farther from x-axis. All right, it's getting farther and farther away from the x-axis. So that's what I call growth. Kind of oppositely, when we look at decay, what we're looking for is for it to get closer to the x-axis, okay? So we're going to get closer to x-axis. So let's see here. When I plug in 0, 1/4 to the 0th power, that's still 1. 1/4 to the 1 is 1/4. 1/4 to the -1st means you're going to take the reciprocal and raise it to the 1st power, okay? You flip the base, flip the base, and then you make a non-negative exponent, okay? So this is just 4. So now when I plot, we go something like this, and same type of deal, and we get really, really close to the x-axis. So here's what I need you to be on the lookout for. Do you guys notice this? Let me change colors so we know it's important. Okay, 1/4. When the a value is a fraction between 0 and 1, okay, something like this, it's going to be decay. All right, so this is what you're looking at, and we're looking at the base. In this one, the base was, I'm off the page. In this one, the base is 2, which is greater than 1. And again, talking about the base. All right, so when you have a base that is greater than 1, you will have growth. When you have a base that is between 0 and 1, you will have decay. And that's what we need for this next section down here at the bottom. When I look at something like number 1, I need you to understand, I don't want to graph this until I have a positive x value, all right? I know the rule. I know what I can do here. I can rewrite this. This is the same thing as 1 over e to the x power. All right, how did I know that? Because if I have a negative exponent, I can write the reciprocal and then raise it to the positive exponent. All right, so now, again, think e is like 2.7. 1 divided by that is going to be a fraction. It's going to be between 0 and 1. So this is very clearly decay. How about on number 2? Do we have to change anything around, or is it written nicely already? I'd say it's good. So we just look. 8/3. Yes, it's a fraction. However, what? It is greater than 1, which means this is growth. When we look down at number 3, again, I see that negative exponent. I don't want it. I don't want it. So I have to write the reciprocal of the base to the positive exponent. And now what do we notice about this fraction? It is between 0 and 1, which means I have decay. And lastly, another one, I have a negative exponent. I rewrite as the reciprocal to the positive exponent, so this is really just 2 to the x, and we actually already did that exact problem up here, 2 to the x. We know that that is growth. Okay, we're getting there. Let's graph. Let's take a look at some of these, and then we will call it a day. Let me move this a little bit. Okay. There are lots of different ways and tricks to learn how to graph these. At the end of the day, guys, a lot of the times I just like to plug in points. If you can get me 3 points, you can get me the general shape of this guy, okay? So here's my thought. What I would really want you to consider here and make sure you understand is that this negative is not being raised to the x power. This is written more like this. Okay, sorry, not a good x. All right, so what we need to do, I'm going to make a little table. You don't have to, but I usually do -1, 0, 1. All right. And what I am going to do is I'm going to very nicely get, or plug in, I should say. So the easiest one is 0. Plug it in. 3 to the 0th is 1. But because there's a negative out front, I have to make it -1. Okay? When I plug in 1, 3 to the 1st is 3. But I have a negative out front, so this is -3. -1, what am I going to do? I'm going to have to do the reciprocal. So this is going to be -1/3. So now when I go to plot all these, -1, -1/3, -1, -3, I can see that, not the best graph, but it's going to do one of those. Okay, and what do you notice? It is still asymptotic to the x-axis, or there's a horizontal asymptote. The other thing I want you to notice is this is still growth, and by that I mean it is still growing farther and farther away from the x-axis, which hopefully makes sense because my a value right here, this 3, is greater than 1. Okay, the negative actually is extremely similar to what we did way back when in chapter 2, I believe. What did we learn? If you have a negative outside of the function, out in front, isn't that just a flip over the x-axis? Okay, this is the same thing that we did before. When you have a negative out in front, not inside the function, it's going to be a flip over the x-axis. Okay? When we look at the next one, you can actually think the same way, and you can say, oh, this negative with the x, now it's inside the function. So technically, this is going to be a flip over the y-axis. But to be honest, guys, I think that's a tough way to think about it. I really, really would rather you guys think about it as I can rewrite this, okay? I want to rewrite this because I have a negative exponent. I'm going to say I want the reciprocal and then raised to the positive, okay? I think that's going to make a little more sense. Now, don't forget about this because we're going to be able to use that to kind of test later or see that we did something right. But again, let's plug in. So 1/5 to the 0th is 1. 1/5 to the first is 1/5. 1/5 to the negative first is 5. So when we go to plot, boom, boom, boom. Oh my gosh, it's exactly what we thought, right? If we just had y equals 5 to the x, we would have been going in growth, up like this. But because of the negative, it turned into decay, and it flipped over the y-axis. Any point that would have been on the original is now flipped over. All right, so that's what we're looking for there. All right, let's keep going. Oh, very similar to the last one, right? Okay, I have a negative exponent. Let's write it as the reciprocal. I don't even know if I have to make a chart on this one. In fact, I'm not going to. 4 to the first is 4. 4 to the 0th is 1. 4 to the negative first is 1/4. We're good with that. You guys can do that one for sure. This next one, okay, here is what I would like you guys to kind of keep in mind here. I have a negative 1 being, a 1 being subtracted inside of the function, okay? This negative 1 is being added or taken away inside the function, and we learned way back when that when you add or subtract inside the function, it is a horizontal transformation. Okay, this is going to be a horizontal transformation of 1 unit. So I'm going to say this has to go 1 to the right. All right. Now what I'm going to do, guys, I'm going to then treat that. I'm going to kind of do that before I even start this. I'm going to say I went 1 to the right, and now I have a new origin. Okay, so I kind of x'd my new origin, and now I treat this the exact same way as if it were just y equals e to the x. All right, because now when I make my xy table and I go -1, 0, 1, well, what do we have? E to the 0th will be 1, e to the first will be e, e to the negative first will be 1 over e. All right, so now this is what I'm talking about. I already moved 1 to the right, and I made kind of my new origin. So I'm going to treat this point as my 0, and so 0, 1 will be right above that. We said that e is about 2.7, so maybe right about there. And then 1 over e, maybe something like that. It's around 1/5. And we can then sketch. All right. Almost done. So close. All right. Notice, I hope you guys notice that this -3 is not being added or subtracted inside of the function like we saw here, right? This -1 was with the x. This -3 is outside. So hopefully you guys remember then this means what? We're going down 3. So what do I want you to do? I want you to go down 3 now. Just think about it as your new kind of origin or your new starting point. If you think about that, then you're more than okay to just make your xy. And let's see, 1/2 to the 0th is 1. 1/2 to the first is 1/2. 1/2 to the negative first is 2. So now I know that from this new origin I can plot 0, 1, -1, 2, and 1, 1/2. Now be really careful, okay? There's one thing I didn't add and I almost just messed up. I have not been drawing in horizontal asymptotes, but all exponential functions have horizontal asymptotes. So it's not a bad idea to understand that the horizontal asymptote that was at 0 shifted down 3 units and is now here at my dashed line. So I would do something like this. Alright, so now the last thing I want to do to finish up, I just need you guys to kind of be aware that a lot of these ideas come straight from what we've already done with transformations, okay? If I gave you something like this before, negative, and let's go negative x squared, we'll do just something like that. I need you guys to remember what? This is a flip over x-axis. This would be a flip over y-axis. It is the exact same thing when we work with exponentials. So if I give you something like this, alright, if I need an equal sign. Let's do that. Sorry. If I give you y equals -2 to the negative x, it's the same thing, okay? Now, I'm not actually going to have you flip over the y-axis. I'm going to want you to do a little bit of work, but I want you to understand that that's what's happening, right? This is going to be your flip over x, and this is going to mean there's a flip over y. Also, the same if I gave you something like this. What did we know? What did we know? This is a horizontal shift. This is a vertical shift. It's the exact same thing again, guys. Alright, an exponential, it just looks a little different. So now I'll have, let's see, 2 to the x plus 3 plus 7. And I need you to understand that this is the horizontal shift. This is the vertical shift. Okay, so I know this was a super long video. It covered about 4 or 5 different things. I'll hopefully review. I hope you enjoy the rest of your weekend. I'm sorry for getting this video out late. And I will see you in class to practice this stuff. Have a good one.